Hi, it's Kiffin Lobates here today from CHEQs Labs, and I'm going to be talking about the rather exciting topic of AI agents making payments, but not just making payments, making them both autonomously and securely. And there will even be a demonstration later on in this video of an actual practical system doing just that thing. It's based on an invention by Richard Piersantini, who is the CTO of CHEQs Labs, and it is something that I think is going to be of interest to a lot of people out there because it can be used to provide the missing pieces for the Coinbase X402 protocol, which is an extension to HTTP, planning to enable internet native payments using blockchain tokens and cryptocurrencies, and the Google AP2 protocol, which is working towards allowing AI agents to assist human beings in making payments. The big piece that's missing at the moment from the big announcement that Google made a week or so ago is the making of payments by AIs without requiring a human being to be present. They've got two of the pieces kind of sketched out. There's a big gap in the middle one, this human not present purchasing capability. So without any further ado, let's move on to a demonstration of how the CHEQs wallet and the CHEQs digital voucher system enable AIs to reliably and securely make these kind of payments without requiring a human being to approve them. Quite interesting stuff, I'm sure you'll agree.
And we're out of the forest and back inside to look at a demo of the CHEQs programmatic wallets in action. And you can actually go and see this yourself by visiting labs.cheqs.com, and then you will see that there is a button to start the autonomous economy. I'll click that and we'll get going, and initially it's creating 4 different entities. I'm going to have to be quick on the pause button. Those entities are a shopper agent, a bad actor, a merchant agent, and a factory agent. And each one of those has had its own wallet with an Ethereum address created, and it has its own password. This is all coded in JavaScript and WebAssembly, so for the demo it's running in the browser. However, the components can be used in standalone software, and of course the different parties would be on different networks on different machines, not all running in one browser on my desktop. So in this demo, the shopper agent is going to be making requests from merchant agents and factory agents for goods. They're going to respond with prices and billing information. The shopper agent is then going to pay, and the merchant or the factory will then verify that the payment is correct and mark that. And we also have a bad actor, which is going to be submitting transactions trying to subvert other transactions between the shopper and, say, the merchant or the factory, and it's going to fail because of cryptographic signatures. Even if it's trying to replace the data in one of the shopper agent's transactions, it's not going to work because the signatures won't match. So I'll fire that up now, and you can see the transactions scrolling along. And the first transaction we've had is a malicious one from the bad actor, trying to fake a digital voucher to pay for goods from the merchant agent. Here we see one coming from the shopper agent. Let me just pause that, collapse the initialization log. So here you can see the shopper agent has requested to buy a custom widget from the factory. The factory agent, using an X402-like protocol, has responded with a price and the payment details, so who to pay to. The shopper agent has then issued a digital voucher, which we call a check, and then it arrives at the factory agent, and the factory agent verifies that the check is correct, cashes it, and then presumably ships the custom widget out to the shopper. And this works because the digital vouchers can be transmitted off-chain, and the factory agent can check on the blockchain that the digital voucher or check is valid and that the shopper agent has enough funds in its account in a smart contract on the blockchain to cover the cost. And when it cashes the check, it can withdraw 812.38 USDC from the smart contract to its own address to cover the purchase. And this will just keep running. The shopper agent will be making requests to the factory agent and or the merchant, getting prices back, issuing payment, and then the seller will verify whether the payment has gone through or not. Whether it's a valid payment. Here we saw one that was not valid. It was again a bad actor. Maybe there were not enough funds, or maybe it was trying to subvert another check from a valid party and substitute its own data into it. That won't work. If you run this demo, you can actually leave this running overnight, and it'll just churn away. It keeps track of how many transactions there are, how many have been rejected, and the total volume of trading. And I left it running last night, and it was up to about 1 million by the time I got back. Now, those of you who know how to use the developer console in a browser can hit Control-Shift-I and call up the console and actually see the JavaScript showing what is going on here, and that includes seeing the data that is being sent backwards and forwards. A request here from, actually I'll pause that so we can see, a request from a bad actor to the factory agent asking for how much component parts cost, and getting a price back, and then in this case producing a bad check which the factory agent is rejecting. If we keep running, we should, in the next transaction, hopefully from a valid buyer, and it is in this case, we can see that it's to the factory agent for component parts, and this time when we go down we can see that it's valid and it's approved. Let me just move my headshot away so you can see. So here we are, the shopper agent makes a request for goods, gets a price back and a message to sign to make the payment. It signs it, and this is the raw signature object. This is effectively a check, and then the factory agent verifies the signature, checks that the balance is available, and authorizes the shipping of the goods because the payment is valid. So that's the demo. I think it's quite a lot of fun. You can sit and watch these transactions fly by for as long as you like. And the neat thing is here is that this is all autonomous. There's no human being involved in approving anything. The shopper agent has its own budget, it has its own account on the blockchain, and it's making payments as and when it sees fit. And as you can see from the bad actor, malicious parties will get detected. They can't fake payment. One of the advantages of digital payments over, say, legacy paper checks, where there were unfortunately cases of bad checks being cashed. That doesn't happen here. I suggest you go and visit labs.cheqs.com. It's open for anybody to have a look at it. You can even have a digging around in the console to see what's going on under the hood as well. That's the demo. Hope you found it interesting.
So there you have it, an agentic AI making fully autonomous payments to other agents or possibly e-commerce sites or even human beings. We've built on the foundations provided by Coinbase in the form of the HTTP protocol extension and Google's AP2 protocol for AIs to be able to make payments. But the difference is that we're providing the middle piece that makes this fully autonomous. You can go and try it out for yourself. Visit labs.cheqs.com. And if you're interested in taking this further, talking to us about partnerships or proof of concept implementations, or even just getting involved, please reach out to labs@cheqs.com and somebody will get back to you. That's it for today. I hope you found this interesting, and I'll see you in the next video soon. Bye for now.